Okay, I think we can start. So, good morning and a happy new year. Very warm welcome to everyone who has tuned in to participate in this webinar. The title of this event is Chartering the Course for CCS, launch of the CO₂ Transport by Ship report. My name is Michał Wendołowski, and I will have the pleasure to moderate this webinar. I work for Bellona Europa, a climate NGO based in Brussels. Bellona is also a member of the Zero Emissions Platform. And we're meeting today for a very good reason, and that is the launch of the report on CO₂ transport by ship, prepared by the Zero Emissions Platform and the Carbon Capture and Storage Association. And I want to congratulate the authors for this very insightful paper. I had an opportunity to read the report before this webinar. And this report comes as a result of a very interesting work done by a working group set up by the Zero Emissions Platform and the CCSA. And it has been written under the leadership of Ian Phillips from Energy Transition Advisory, Haije Stigter from Carbon Collectors, and Martin York from Storega, with inputs coming also from multiple CCS and maritime shipping experts. So we're about to learn more about the content of the report. But before we do that, I wanted to introduce two of the co-authors of the report who are joining us today. So we have Haije Stigter, who is the technical director at Carbon Collectors. Haije holds a master's in marine and industrial engineering and has 20 years of experience working at Shell, operational and asset management and business improvement. Since 2017, he co-founded Fizzy Transition Ventures and became involved in the development and design of the Carbon Collectors CCS solution. So thanks for joining us, Haije. Then Ian Phillips is the director at Energy Transition Advisory Limited, a specialist consultancy offering technical and commercial expertise in the energy transition. Previously, Ian managed projects and undertook business development for Storega Limited, developing, among others, the Acorn CCS project. He is an MBA qualified chartered petroleum engineer. So welcome, Ian. And now Haije will give us a short presentation of the report. And after that presentation, he will stay with us together with Ian, who is another co-author, and we are going to have a panel discussion about the topic of CO₂ transport by ship. So Haije, the floor is yours.
Thank you, Michał. So Kirsten, can you please flip to the next slide? And the next slide, indeed. So next slide, indeed, Kirsten, thank you very much. So indeed, just to remind you that when we started this venture, I guess, earlier last year, obviously we had a couple of objectives, which was building on a report that was issued in 2022 on CO₂ shipping, but that focused on shipping only by itself. And there was a need to identify indeed what was the potential for shipping of CO₂ in Europe. So the objectives were to map and to identify the requirements for shipping, looking at planned projects and identifying the potential shipping routes, estimating capacities and fleet sizes, and to determine whether interoperability of CO₂ transport by ship was beneficial or not. And we'll touch upon that later during the presentation, and identify the regulatory and commercial barriers and enablers for commercialization of CO₂ by transport by ship. Now, it's all very small, but we actually had quite a large working group. And I would like to indeed thank all the contributors and the editors to the report, which I think ultimately resulted in a very good piece of reference material for policymakers and involved alike. I would like to single out the people from Slaughter MA, who in my opinion delivered an excellent comprehensive narrative on the regulatory and commercial barriers and enablers to commercialize the CO₂ shipping. So if we go to the next slide, please. It's important to understand there's no uniform shipping condition. And we've included in the report the definitions of the various shipping conditions that are being considered, being from low pressure, medium pressure to high pressure. And each one of those will have advantages and disadvantages. But the low pressure shipping is around 6 to 7 bars minus 50 degrees Celsius, so very cold. The medium pressure shipping is around 15 bars minus 27, minus 30 degrees Celsius, which happens to be the Northern Lights shipping conditions. And the high pressure conditions is around 40 to 45 bars with temperatures above 0 degrees, around 5 degrees or 10 degrees Celsius. And for each one of those, there will be different compositional requirements, but the general considerations will be looking at the impurities and the in the CO2 stream. What are the effects of health and safety? What are the effects on the integrity of your system? And what are the effects of specifically the inerts and the non-condensables on the phase behavior? Also important to understand, because we're looking at shipping is just a element in the CCS solutions. And it could be shipping from source to sink straight, but it also could be shipping from terminals to stores or terminal to terminal. Is that, and it's likely then to be that the CO2 will be delivered by pipeline to the terminals. And in general, the shipping specifications are more stringent than the pipeline specifications, so that it makes sense to do conditioning at the collection point rather than at pipeline entry point. So we're looking at end of pipeline solutions to get the CO2 onto the ship. So at terminal conditioning rather than at pipeline entry conditioning. Go to the next slide, please, Kirsten. Thank you. Now, in terms when it comes to mapping the potential market of shipping by 2030, of course, that was one of the objectives. It's like looking at a relatively short time frame. It's within the next 7 or 8 years. We basically looked at the Trans-European Network for Energy list, the PCI, PMI list, the projects of common interest and the projects of mutual interest, which might or might not have happened given the status already. But if you look at 2030 and you work back, when would you need to take FID to be operational by 2030, then the latest you would take FID or would expect to take FID would be 2028. So we looked at the time frame where those PCI and PMI projects are expected to take FID. So we looked at the 2023 to 2028 time frame. Obviously, Northern Lights has already taken FID, and Porters is in there, has already taken FID, but Porters doesn't include the shipping element. Then we filtered all the PCI, PMI projects to look at which ones would include shipping, and then you'll end up with a low volume and a high volume of expected volumes for shipping. The lower end of the volumes happens to be the Northern Lights volumes, but the higher ends of the volumes could be up to 40 million tons per year. Then we applied another filter in terms of what are the likely ones that are going to be realized, and we ended up with a volume difference there. If you look at all the volumes, you would be requiring 6 to 40 vessels. But then if you look at the likely volumes, you'll be looking at the fleet size, which could be between 20 vessels, which actually falls behind the targets to achieve the Fit for 55 targets. So there is a clear, if you look at, and this little map, and there's more details obviously in the report, it looks at emitters and storage projects. The storage projects are the darker maroon red, with the emitters clusters in the lighter orange ones. There you see that
Sorry, you unmute?
I unmuted myself, sorry about that. So I'll go back to the little map, and there's more details in the report. This is actually a map produced by the Clean Air Task Force, but the darker circles, the maroon circles, represent storage sites planned, and the lighter orange circles represents the emitters or location of emitters. You will see there is a distribution of storage sites which focuses around the North Sea, and the emitters are distributed around Europe. So there's a clear need for cross-border transport within the EU or EEA. And important to understand is that currently the development of storage is lagging the development of carbon capture projects. So there's definitely a need to get those aligned. Various business models can be assumed when you look at shipping. It could be a pickup service by the storage provider, like in essence Northern Light is doing. It could be a drop-off model by emitter, and the only one I know of at the moment would be Yara, which would ship small volumes of their captured CO2 to food-grade volumes to users, whether it's the beverage industry or the food industry. And then there could be a model where we were looking at independent shippers and the intermediaries, and a number of these shipping companies are presented in the forum as well as in the presentation today. If we go to the next slide, please, Kirsten. When we look at interoperability of CO2 transport by ship, I think I've indicated in the beginning that we did not land on one transport conditions, nor is it my opinion that we should to do so, but we should consider the full value chain to select the appropriate transport conditions. So you could be thinking about, is it a source to sink solution straight from emitter to source storage solution? Is it a terminal to terminal solution? Is it a terminal to store solution? Or is it a emitter to terminal solution? And each one of those will have different merits, considering volumes and distance. And you might consider, or you might select either low pressure, medium pressure, or high pressure. And each one of those will have then advantages and disadvantages when it comes to ships designs, but also comes to, for instance, energy required for liquefaction. Obviously, there's a density impact, so the higher the pressure, the less density, so therefore the less payload in the same volume of cargo space. It also will have an effect on the materials required for the pressure containment system. It also will have an effect on the maximum sizes of your pressure containment system or the individual tanks. It has an effect on the energy requirements of liquefaction. It has an effect on the tolerances of impurities or inners on the non-condensables. And it will have an effect on the required installations and pressure management systems on board the vessel. So therefore, you need to be looking at it from a full value chain perspective and select the best transport condition that basically matches that value chain. So it's a complete techno-economic analysis from source to ultimately to sink. When it comes to compositional requirements, as I've mentioned before, in general, there's three criteria you need to apply. You need to look at the impurities and the effect it might have on health. You need to look at the impurities and need to look at the effect it might have on integrity of your system. We know that CO2 with free water will provide a corrosive environment. Hydrogen will have an effect on your material integrity as well, but also a combination of your sulfur oxides or the nitrogen oxides with oxygen and H2S without water may actually provide a corrosive environment as well. So you need to look at a case-to-case basis. What is the acceptable impurities in your CO2? The CO2 stream is never 100% pure. And then in addition to that, you need to be looking at what then specifically inners and the non-condensables, the methanes, the hydrogens, the nitrogens will have as an impact on your phase behavior. And the tolerance of your phase behavior, again, depends on your transport conditions. Now, the Society of International Gas Tanker and Terminal Operators are recommended changes to the International Marine Organization, and specifically regarding to the International Gas Code, which applies to gas tanker design at the moment, to specifically make it more specific to CO2 as well, as the in general, the gas code at the moment looks at flammable or explosive gases where CO2 in essence is inert. So that's a good move. And then the European Commission for Standardization, the CEN, installed a new technical committee that looks at building on the ISO standard TC 265 to recommend changes to that as well. This is a quote we picked up from a DNV Joint Integrity Project. I think it's important to understand is that to make, I guess, the market as competitive as possible, it is not desirable to limit the need for cleaning CO2 of harmful impurity by keeping its composition as wide as possible. So don't try to limit it to the smallest, I guess, denominator, because that will become cost prohibitive for ultimately the emitter or the shipper. Go to the next slide, please, Kirsten. As I said, the people from Slaughter did quite a bit of extensive and impressive piece of work, in my mind, on looking at the barriers and enablers for commercialization of the CO2. And I will not touch upon all of them, but I think the ETS system at the moment as it stands, the emitter will only obtain the right to subtract the captured and stored CO2 once it is transferred to a permanent long-term geological storage. And this requires a clear protocol for metering, accounting, and allocating, specifically when you look at multiple sources into a system or a terminal or into a ship, and then accessing multiple stores. This is not necessarily developed yet, and I think there's a clear requirement to do so. Also, there's lots of geological storage available offshore, North Sea, which seems to be the focus in Europe at the moment, although Denmark is now looking at onshore storage as well. Countries like the Netherlands or Germany will not consider that. But we are excluding huge potential both for stores and CO2 that need to be stored by the fact that there is now a barrier between the EU ETS and the UK ETS systems, which impedes the opportunities and scaling up opportunities. We would basically propose to create a level playing field when it comes to funding support to those emitters that can easily connect to backbones of pipeline systems, like in the Port of Rotterdam, versus those emitters that are depending on shipping because they're away from the port or away from the terminal. The Netherlands, by the way, with their SD++ subsidy scheme, are already making a differentiation, so that's good. So they allow for higher subsidy amounts when we look at liquid transport, which is shipping rather than gaseous transport feed into a pipeline system. And the fact that most funding schemes at the moment basically are based on the competition, it does not create opportunities to aggregate and commingle smaller volumes of CO2 sources, where you can actually achieve, when you bundle those, you can achieve scale and reduce unit cost and make those competitive as well. We go to the next slide, please, Kirsten. So key recommendations, indeed, I think it's recognized that shipping will be required and an important element to achieve climate goals. So therefore, we like to believe that the policymakers across Europe should support the development of CO2 shipping. There's a bit on... so we don't necessarily believe that it should be regulated, but that it can develop based on commercial basis. In addition, we would like to see that the EU and the UK basically start entering into active discussions to end up with an agreement that that CO2 either originated from the EU or the EEA can be stored in the UK and vice versa without losing ETS allowances. And then last but not least is that there is still the London Protocol, which needs to be amended, but at the moment for cross-border transportation there will be required bilateral agreements between the countries. So we would expect that to be accelerated as well. I would like it to leave it at this.
Thanks, Haije. That's great. It's already a very good basis.
So there was one last slide, but I will keep it as the last slide. One comment indeed. I mean, very important. We understand that storage is lagging behind the development of carbon capture projects. So the development of sufficient geological storage is very important. A key barrier to that at the moment is the permitting processes required to either make stores available in aquifers, saline aquifers, or convert production facilities or production locations to stores. So we would like all, I guess, EU members or European countries to see whether they can accelerate that permitting process to make stores available sooner rather than later. And I'll leave it at that. Thank you.
Thanks, Haije. So as I said, that's already a great basis for our discussion in the panel. So alongside Ian, Haije, and myself, we have a couple of other panelists. So I'd like to welcome Johanna Fiksdahl, who is a policy officer at the European Commission at DG Energy. And Johanna is working on the industrial carbon management strategy. Johanna is also a seconded national expert from Norway to the European Commission, and she has more than 10 years from the Norwegian Ministry of Petroleum and Energy, and was a special envoy for 2 years as an energy counselor at the Norwegian permanent delegation to the OECD and IEA. I think Johanna is already with us. I remember that she was supposed to join a bit later, but I hope she's already here. And so welcome. Then Andrew Russell, who is the CCUS policy manager at the UK government, the Department for Energy Security and Net Zero. Andrew has worked in the UK civil service in a variety of energy policy roles, including in industrial energy efficiency and oil and gas development. Since 2019, Andrew has worked in the CCUS program, focusing on policy to develop CO₂ transport and storage networks, including onshore and offshore regulatory frameworks and non-pipeline transport. Thanks for joining us, Andrew. And then Panos Deligiannis, who is the head of shipping at Ecolog. Panos has 25 years of technical and operation marine experience as technical director for ship owners in Greece. And prior to his shipping career, he obtained a PhD from Liverpool University in mechanical engineering, and he undertook scientific research in the fields of cryogenic storage and transportation, upstream crude oil, and nuclear. So welcome, Panos. And finally, Boris Dolek, who is the shipping commercial manager at Northern Lights, a company that is expanding its CO₂ carriers fleet. And at Northern Lights, Boris works across business development and shipping. Boris holds an engineering degree and an MBA and has extensive experience in CCS, which he gained in the USA, Australia, the UK, and Turkey. So great to have you with us, Boris. And now we have about 35 minutes for the discussion. And I'd like to invite the participants to ask your questions using Slido. And if you have a question, it would be also maybe good to specify to whom you'd like to address the question. So maybe I'll start with a question to Panos. Do you consider maritime shipping of CO₂ to play a pivotal role in a multimodal CO₂ transportation system? Panos, what do you think?
Yep. Thank you for having me. I think it is quite an important role that shipping has to play, because shipping is an integrator, and this is because of its character, global character, a quick construction, quicker than a pipe network, modularity that can allow a phasing of the industrial decarbonization, also providing resilience with respect to transportation and storage, meaning that a number of ships can use as a backup in case of failure, both to transportation and to storage. And it's unlikely that any permitting requirement or social acceptance will play an important role in delaying deployment of CCS.
Thank you. So now moving on to Boris, I wanted to ask you about Northern Lights, to give us a bit of a status or update. So we know that you guys have been very active in the CO2 shipping market, and in December, Northern Lights entered into a charter agreement to expand its fleet with the fourth CO2 carrier. So my question is are these speculative orders, or maybe could you give us an update on your activities?
Sure, Michał. Hi, everyone. Thanks for having me. It's very exciting times for Northern Lights, and it's also very exciting for CO2 shipping. In 2021, we signed an agreement with the Norwegian state. The agreements covered two industrial customers, the Heidelberg cement facility in Norway and also the Celsio waste incineration facility in Norway as well. This project is called the Longship project. So the two customers came from this 2021 agreement. Then last year we announced the world's first two cross-border commercial CCS agreements. So one of them was with Yara Agreement in Netherlands, and the other one is with the Ørsted company in Denmark. So with 4 customers signed, we now have binding agreements to transport and store 2 million tons per annum of CO2. So we ordered 2 ships in 2021 and 2 more last year to accommodate for these contracts. Michał, back to you.
Thank you. So now moving to Johanna, I hope you are already with us. Yes, I can see you. So welcome again. So I'm not sure if you had a chance to look at the report and the recommendations. I hope you saw at least during the presentation by Haije what recommendations he suggested. So I wanted to ask you to tell us, how do you envisage the role of the European Commission in building EU-level support for CO2 transport by ship, especially in the context of the upcoming industrial carbon management strategy?
Thank you, Michał, and also thank you for inviting me to this discussion, and sorry for being a bit late. So I think, first of all, in the upcoming strategy that we are now developing, CO2 shipping will also be a key part of the transport infrastructure. And so I work in DG Ener, and the key focus for DG Ener is how the transport infrastructure will work as a key enabler to bind the different parts of the value chain together. So it could be by pipelines or ships or rails or trucks. All of these different modes of transportation are included. And more specifically, we're also looking at the study now how to optimize the grid in Europe. So the Joint Research Center is working on the modeling now with different scenarios. They presented the Net Zero Industry Act scenario at the CCUS forum in Aalborg. And in this study, we tried to look at how we think the transport infrastructure might develop in Europe, given different assumptions. And in this study, we use mainly pipelines, but also CO2 shipping, because we know that CO2 ships will be a quite flexible way to transport the CO2. This study will aim to be finalized quite soon and will also be incorporated in the work of the strategy. However, in the strategy or in this study, we assume that the cost of CO2 shipping is the same as offshore pipelines, because it's beyond the scope of this study to estimate the cost of CO2 shipping. But I think this will be quite a relevant topic to follow up upon as a next step for our work and for the JRC, in order to understand how we can build the transport infrastructure in a cost-optimized way. So this is one area where I think CO2 shipping is important. And another topic that I want to mention is the work that we are now developing on preparing standardization work to specify minimum standards for CO2 transport for both transport and storage. And I think the experience from Northern Lights will be very relevant, but also from other projects, in order to understand how to balance the cost and the risks in the value chain. So these are some appetizers from me. So back to the studio, Michał. Thank you.
Thanks, Johanna. And now we have another policymaker with us. So I'm turning to Andrew from the UK government. So Andrew, you're working specifically, among other things, on non-pipeline transport of CO2. So how is the UK government planning to support CO2 transport by ship in the UK carbon management strategy or policy?
Great, thank you. Firstly, thanks very much for inviting me today for the panel, and also really welcome the comprehensive report that's been published. I think it's an excellent report, and there's a lot of detail in there. So thank you for the work that's gone in there. I think for those that might be familiar with the UK government's approach to date on CCUS, we've predominantly focused on establishing CCUS in the UK using clusters which support transport of CO2 via pipeline. But we recognise that around half of the industrial emissions in the UK are outside the main industrial clusters, and non-pipeline transport options will be required to help decarbonise those emitters. We recognise that non-pipeline transport, and particularly CO2 shipping, could also help improve store resilience and the transport of future international CO2. So we've been engaging closely with industry on the potential options for CO2 shipping networks and how these might be integrated into the wider CCS landscape we've already created in the UK. Specifically in December, we published our vision for a new competitive UK carbon capture and storage market by 2035. I'd encourage those that haven't seen it already to kind of have a look at that, but that really sets out how we see, amongst other things, the role on non-pipeline transport in the future. So we stated that we anticipate that non-pipeline transport projects will be eligible to apply for an emitter selection process that will open in 2025 onwards to meet our UK ambitions, which is to capture and store 20 to 30 megatons of CO2 by 2030. We've also announced that we'll shortly publish our initial proposals on how we think that non-pipeline transport would be delivered in the UK. And furthermore, we are considering amendments to our business models to look at how we support the financing and appropriate risk allocation of CO2 shipping and non-pipeline transport more generally, and also how we might adapt our CCS network codes, which is something we designed specifically in the UK to look at the interface points between emitters and storage sites. We've also published in December as well a market update on the Track 2 cluster sequencing process in the UK, and the report mentions a couple of the UK projects, Project Acorn and Viking, which are kind of some of the key projects in the UK that are developing CO2 shipping concepts at the moment. And we've stated that we want the cluster expansion plans to recognise both pipeline and non-pipeline solutions. And then just finally, on the regulatory side, last year we enacted an Energy Act which contains some substantial CCS provisions, one of which included enabling the scope of licensable transport and storage activities to be extended to non-pipeline transport should this become appropriate. And the report recommends not regulating non-pipeline transport, we've added that flexibility in the future if we think that there's that need to kind of regulate, but that's not something we've taken a decision on yet. Thank you.
Thanks, Andrew. So in the meantime, I'm looking at Slido, and we have already some questions. Kristen, I only see the 4 questions that are showing on the screen, so I'll start with these. Does the report include the 21 UK storage licenses? Morecambe Net Zero has a capacity of 1 gigaton and 25 million MPTA, with ABB developing shipping at Barrow Port. I suppose that maybe that could be a question to Ian, perhaps, and Andrew, although, yeah. Ian?
If I could comment, the main reason is simply that this report was focused on the shipping requirements by 2030. This project in the Morecambe Bay area has indeed got very significant storage and very significant potential emissions, but because it is not currently in a significant funding program, we decided to, well, we took a view, shall I say, that it was likely to happen later, and as a reason, that's the only reason it's not included.
Okay, makes sense. Then we have another question from the online audience, and that's, I suppose, for Andrew. Has the UK government consulted on the question of whether the UK actually wants to accept emissions from EU emitters for storage?
Sorry, can you repeat that question? Apologies.
Of course. Has the UK government consulted on the question of, sorry, just jumped. Has the UK government consulted on the question of whether the UK actually wants to accept emissions from EU emitters for storage?
Okay, thank you. Yeah, no, so the UK government's been very clear that we see a role in the future for UK kind of offering CO2 storage services. At the moment, we've set out our ambition to enable cross-border CO2 transport storage networks, and indeed we've kind of made our response kind of clear to, for example, the industrial carbon management strategy the EU has run, and we stated our ambition around that. We feel like with the 78 gigatons of CO2 storage capacity we've got in the UK, that we think we can play a role within the region. We haven't specifically consulted on whether individual kind of companies or others would want to accept that, but we've opened up, as was mentioned earlier, the licensing round, which was recently run. A number of those storage sites are kind of interested in both import and export of CO2. So we will be, as I mentioned earlier, we'll be seeking evidence in relation to non-pipeline transport and the deployment of CO2 shipping this year. And so we may well ask questions on this as well, but it's clear from the UK government's position that we want to enable those networks in the future.
Okay, thank you. So I'll go back to online questions in a bit. I just wanted to ask, I suppose that would be a question to Haije, Ian, and perhaps Panos. What role and requirements would you see for ports in the development of CO2 transport by ship? So maybe I'll ask Haije first. I think you're still muted.
Yeah, sorry.
Yeah.
I had difficulties unmuting. I think, I mean, you know, not all emitters are located in a port, although there's a fair number. So there will be terminals developed to aggregate volumes from either inland volumes or volumes from that are being delivered by inland barges, road or rail. So two ways. So there will need to be terminals that can aggregate volumes of CO2 where it can be collected and be transferred to a storage site, very much similar to the Northern Lights model, where it's actually being transferred to a terminal, but it also could be to direct offshore injection. And port authorities might play a role as well, where you might look at differentiating port fees based on cargo rather than looking at tonnages. where it is attractive for, or at least to keep the cost down for CO₂ shippers, to make it, I guess, more attractive for the shippers to service and enter those ports.
Okay. I don't know, Panos, do you have a view on that?
Yeah. Well, although I'm not an expert on these port and port authorities, I think their role with respect to clear political leadership and strategy with respect to facilitating the development of a terminal is very important with respect, firstly, to data requirements for the investors to assess the suitable location in order to optimize this aggregation, provide the area for development, and timely provide permitting and assist in the studies required for impact assessment or decision making for the environment versus a cost offsetting, the navigation and mooring studies, and also the social acceptance. They play a key role to local community, and that will be a showstopper sometimes for investing in a terminal.
Okay, great. Thank you. So back to our online questions. So I have one here. To which extent, it has two questions, in fact. To which extent direct injection from ship to storage can be a mainstream solution? And what are the main hurdles of CO₂ direct injection projects? Who would like to take this one?
I can answer that one, Michał, if you would like to.
Thank you.
I mean, if you consider the fact that, first of all, it's possible. It's just a reverse process of what used to be done, like collecting crude from offshore production facilities and bringing it to a terminal or to a user, to a refinery. We reverse that process and we basically collect the CO₂ at the store and deliver it straight to an offshore storage site. So it is basically already a mainstream solution. It's technology that is available. Offshore mooring is available. Offshore injection is also available. So there are no real hurdles as it builds on existing technology. So shipping, offshore mooring, offshore injection, offshore storage, it's basically a reverse process of gas production. So it is mainstream and there are in essence no hurdles.
Can I add just a comment on that? I think if we look into the whole operational mode of direct injection from a vessel, then that will include quite large energy requirement, power for increasing the pressure to dense phase, and also heat up the CO₂ liquid phase to above 5 to 10 degrees centigrade. Also, there is a requirement for a good management, so there is a continuous flow since there will not be any buffering. And I think without being expert on that, the continuous flow is quite crucial when you start the injection.
Right. I'd like to make one comment on that, actually two comments, but the transport condition, high pressure transport conditions, so at 40 bars or 35 to 45 bars and temperatures above 0 degrees actually facilitates direct injection without the need for additional heating. All you need to do is increase the pressure to the injection pressure, which is a relatively modest power consumption. The the continuous process is not required. So intermittent injection is very feasible and is proven to be very feasible for shipping solutions as well. So this is where I mentioned before, you need to be looking at the whole value chain, the full value chain, which will determine your transport conditions. If you transport it at high pressure or ambient temperature conditions, then that will facilitate direct injection with only increasing the pressure and no further processing required.
Apologies, I should mention low pressure, medium pressure. Okay.
Okay, so since we're talking about pressures, I want to bring Boris in and ask about the Northern Lights sort of approach to this. So do you think that CO2 can be shipped, well, I guess it can be shipped under different types of low, medium, high pressure, but how do you and particularly Northern Lights see these conditions being adopted in the market over time?
Thanks. For the general audience, one thing that separates CO2 perhaps from likes of LNG, LPG, and even water is, as presented earlier as well, that CO2 to be maintained in liquid form has to be kept under significant pressure. So the minimum is around 5.2 bar, but then we are looking at alternative pressure levels, right? Low pressure around 8 bar, medium pressure around 15 bar, and potentially high pressure around 45 bar. So earlier as presented, Northern Lights selected medium pressure around 15 bar regime. When we look at today CO2 shipping, there are, I think, 4 relatively small scale ships on water transporting food grade CO2. These are around 2,000 cubic meter ships, and they all operate under medium pressure. So all we are doing at Northern Lights is really take the proven technology and upscale it. Our ships are 7,500 cubic meters. In our view, and based on our discussions with design houses and shipyards, medium pressure can easily be upscaled to 20,000 cubic meters. And it makes sense to go up to that level. So when looking at the pressure selection, of course, there are many criteria, and it's covered in the report that ZEP is launching today. But if we boil it down to the high-level discussion here today, one thing is technological maturity that medium pressure offers today. And the second one is the cost. And cost is not just the unit freight, but whether it's fit for the trade, fit for the customer, and whether the ship is fully utilized are the considerations. So basically, that was our consideration. When we also look at perhaps CO2, we have to consider that CO2 is a very dense cargo. For example, LNG has a density of less than 0.5, but CO2 is, depending on the pressure level, around 1 or even above 1. If you look at Northwest Europe, most of the sailing distances are very short. So, for example, for our typical customers in Northwest Europe, we are looking at between 4 to 7 days round trip distances. So when you combine dense cargo, short distance in Northwest Europe, you would be surprised that relatively small or medium-sized ships can transport very large quantities of cargo. For example, our 7,500 cubic meter ship can transport between 0.4, 0.5 megatons per annum. So that's why we believe in Northwest Europe, the majority of shipping, and there may be different views, of course, on this one, majority of shipping in Northwest Europe will be medium scale, medium pressure, relatively small to medium-sized ships that transport AB, short distance trade. Different parts of the world will need different solutions. For example, if you look at Asia, we look at future trade-off possibly from Japan and South Korea to Indonesia, Malaysia, and Australia. Those long distances will require, of course, one larger volume, but also probably larger ships, and probably those will be low-pressure ships in Asia. In Northwest Europe, if you say, what if 10 million tons will flow AB, does it make sense to have these small to medium-sized ships? Why don't we have larger ships, low pressure? One could argue that then in Northwest Europe, you could have a pipeline that can do the job at this maybe cheaper. So then low pressure ships may really compete against pipeline alternative in Northwest Europe. And of course, as highlighted, high pressure direct injection may also play a role in the future as well. Thanks.
Thanks, Boris. So I am conscious of our time, so I'll just take one question from Slido. Who are the greatest? Before I then ask some questions to the panelists, to Johanna and Andrew. Who are the greatest opponents to CO2 shipping, and what are their specific objections? Hi, Ian. Do you have a view on that?
So if I can comment, I honestly haven't heard material objections to the concept of CO2 shipping. It's clearly, I think the challenges are more to do with the complexity of the value chain, because you have potentially multiple sources coming together at a port. You've got somebody needs to process the CO2 to a shipping condition, which might be the shipper, might be the storage operator, might be the emitter, and then you've got to process the CO2 at the other end. So I think it's not so much the opponents as the challenge is one of commercial complexity along the value chain, rather than anybody saying it's a silly idea.
Yeah, I haven't heard much opposition to CO2 shipping either. And anyone has a quick comment on this? Otherwise, I'll move on to other questions. Okay, I don't hear anything. So I wanted to ask Johanna and Andrew. So as policymakers, what kind of input or actions would help you in your work to support the deployment of CO2 shipping? So maybe, Johanna, would you like to go first?
Sure, thank you, Michał. So as I was mentioning earlier in my remarks, I think it would be very helpful to understand more about the cost side of CO2 shipping, also compared to other modalities of transport. So if you have estimates on that, or if you're going to work on that in the future, that would be very useful both for us and for the work of the Joint Research Center. Thank you.
Thank you. Andrew?
Thank you. Yeah, I think I'd echo some of that point. I think when we're looking at a nascent sector, we're always looking for more information on how the entire value chain will function. And that's some topic that's kind of cropped up today, and a better understanding of the associated costs and the risk sharing. So information on the interface between, say, the port and the ship, and how this links to the emitter, will help us with future funding decisions and the development of the appropriate regulatory frameworks. I think the other area, when we're talking about enabling interoperable cross-border networks for shipping, is kind of helpful to have an industry standard or standards that could be developed that would, help outline the terms for CO2 transport itself. I know we talked a bit about that today, and then also the infrastructure. So, ensuring that things like import-export terminals are consistent across the European region, so you can have those movements of ships between ports, have that kind of flexibility to use the ships in the way that they can facilitate decarbonisation across the region, so that you don't have certain ports that are inaccessible or certain ships that can't go in certain areas. I know, I accept that there'll be variability, and we won't have always the same sort of size of ships, but if we can have some standardization in terms of specifications where applicable, I think that would be very helpful to kind of kickstart the industry.
Thank you. I think maybe I can ask one or two more questions. So I'm looking at slide again. So is it legally possible for middle market players to take on ETS liability from emitters? Or can ETS liability only be cancelled if stored and not transferred? I don't know, would Panos, do you think you could take this one?
I think it is stated in the ETS directive that the operator of its element of the value chain has the liability of any release or vending or fugitive gas. And initially it was pipe network and terminal, and I think with the directive 2023/959 shipping and and rail, I think, that are also included. So yes, the liability passes to whoever has the volume and is responsible for the transportation and any emission coming from that transportation. So that's my interpretation.
Mm-hmm. I don't know, Johanna, is this something that you're dealing with, or I suppose that's probably more DG Klima sort of purview to give us their interpretation of the law. So I don't know if you want to comment, or I can maybe try to quickly ask one more question.
Yeah, just to confirm that the ETS directive lies with DG Klima, so I don't have the details on that, unfortunately.
Yeah, no worries. So what can be done to accelerate construction of CO2 transport ships, considering the demand for shipping other molecules, particularly LNG? So very quickly, if someone could take this one, and then I'll hand it to Joop.
I can take this one.
Yeah.
Well, according to our investigation with Korean and Chinese yards design offices, the initial design will take about a year to 15 months to build up the details of the design. A year after there is a delivery of a vessel, and then every vessel will take another year for the delivery. So I think it's vital that we, as a CO2 transport community, we do prepare for the development of the different designs, starting first with recognizing all the unique characteristics of CO2. And I think this report is quite useful in bringing up the all that details and shortcomings that we're going to face during operation. So we can shorten this initial 15-month period of studying the design by doing that now, and also including a number of research work also included in the report, very useful with respect to composition, different elements, how they react to different temperature and pressure, the non-dissolved gases, and how these can be handled by the terminal and not the emitter, and a number of things that are quite related to triple point and the quite heavy cargo as the CO2 is.
Mm-hmm.
I'd just like to quickly add to that, and this is in with my hat on as a technical director for carbon collectors. We've already completed the design for a 5,500 cube CO2 carrier. We use tug barge combinations. We already have approval in principle received from Bureau Veritas. So we're basically ready to start building. And what we need to accelerate construction basically is long-term commitments from emitters to basic contracts to basically be able to finance the projects. But we're ready to build, and we've got availability here in yards in the Netherlands. So it's basically getting commitments from emitters to take this, or basically to procure the service from us.
Mm-hmm. Great, thanks a lot. And unfortunately, we were not able to take all the questions. I see there are still many of them, and I can see we were almost 200 participants in this webinar. So this shows this is a really relevant and timely topic. So maybe another Q&A session, another webinar on CO2 shipping is needed. But I leave that to ZEP and CCSA to decide. And I'd like to pass on to Joop Hazenberg for a quick wrap-up of this session. Thank you.
Thank you, Michał. For those who don't know me, I'm Joop Hazenberg. I'm the Secretary General of the Zero Emissions Platform and also EU Director of the CCSA. So I'm really happy with this combined report of the two associations on such an important and timely paper. I just want to bring you through the highlights and insights. It's clear that with the shipping alone, we can reach up to 40 million tons of CO2 transport capacity by 2030, which is great because in the end, we need to gear up to a gigaton market of CO2 if we want to achieve the net zero targets of the European Commission. Well, there's lots of challenges, but also opportunities. Things to tackle are interoperability, what kind of shipping routes are needed, and also the shipping conditions, which can actually get quite technical. Another really important part is the need for business models for shipping. So really happy that the authors have also fleshed out the challenges and the questions here. And we really hope that this will help policymakers to building the right framework for deployment of the CCS ecosystem, which is now burgeoning and which you really need. So this is the very good timing for this report. Some specific insights to highlight. The shipping specs seem to be more stringent than those for pipelines. It's something I was not aware of. One concern, and this is something that is on top of my mind, is that many of those shipping routes will actually be in the North Sea region, which is really the hotspot for the CO2 ecosystem. And we need shipping, or we need CO2 storage and transport solutions across Europe, because this is not just an issue for the countries around the North Sea, but we need a fully developed CCS ecosystem across Europe. So this is really something that needs to be at the top of our mind. Storage clearly is lagging behind due to the permitting issues and other issues, for instance, around business models that need to be resolved. I just want to mention the Net Zero Industry Act, which is about to be adopted quite soon in the next few weeks, I dare to say, by the European institutions, which can really help unlock this market also because the NZIA details a 50 million ton CO2 storage injection capacity by 2030. One thing that also was interesting was the really wide range of shipping volumes that has been identified, ranging from a few ships to many. So what kind of fleet do we need? What kind of fleet is expected? And do we have to build new ships for this CO2 transport, or can we actually repurpose existing ships? Also bearing in mind that we're talking about international waste management. I cannot reiterate this point enough. This is not, as let's say in a renewable energy world, where you actually create energy, but you really have to deal with the waste product. So the system that we are trying to devise needs to build from scratch. And it also really requires the right mindset from policymakers to be not too prescriptive, also let the market forces do their work. But policy also makers also need to decide how to approach the interoperability, the allowances for different transport conditions, but also really think about network codes and ISO standards, because it's really the bread and butter of creating such systems. Two new words I learned are corrosive environment and intermittent injection. So I'm very keen to learn more about that. The authors also rightly identify the lack of linkages between the UK and the EU ETS market. So this is also a major hindrance for the CO2 market at large. Once again, we really need to start working and thinking about this as a community to resolve this, and because the UK and EU are, in a sense, together with Norway, really key in creating this European-wide CO2 market. So once again, thank you all for the contributions from the authors. First of all, the Secretariat from both the CCSA and the ZEP delivering the report, everybody that contributed to the report, and I'm really, and of course, everybody in the panel. So please read the report in the link below. And if you have further questions, then please contact us, because we really need to have a lot of dialogues around this important topic. So thank you all, and wishing you a very nice and sunny day.
Thank you. Bye.
Thank you.
Thanks.
Bye.